Singing my life with his performance right. We will have 3 minutes to take a break, and you can get food and drink over there.
Xong ở đây hả?
Cao quá chị. Ô mà
See the presentation you
hả?
presentation you need. Next presentation.
JavaScript.
Ngồi cho hàng đầu hết là tiếng sao đi chơi.
Ở live không?
Ai phải hồi đi hả? Một người coi nào.
À, đó, anh Hùng. Hey dude, you're here today.
Chừng cao quá. Lúc nó lên lại thôi. Nó lại cái lại một lần.
Mình cứ đánh cà phê cái hát cái tiền thôi. Mấy cái đầu cũng được hết. Chơi kiểu
Màu nữa.
Nếu tập bài làm sao lên solo không?
nhá.
Tuấn. Tuấn. Tuấn.
Go here.
Dance. She makes fun of you. She makes fun of you.
Why? Anh kia nói 10 cũng lại được. Như biết ra cái gì? Prototyping là
Hello. We will get back in 1 minute, so
principal prototype.
please return to your seat.
tháo loại của công
Hello. Please remember to fill in the feedback form, so I will get back the feedback form at the end of the last presentation. The point of this event is for everyone to learn new things, to share experience, or become more motivated. So it will be our pleasure to have you as presenter in the upcoming event. So let me know if you are interested in presenting a helpful topic for everyone. Now we will get back to the last presentation presented by Mr. Trung Dan. Please welcome him.
Good morning, everyone. Please allow me to introduce myself. I'm Trung, senior software engineer from Habidash. Okay, today I'm standing here to introduce you how to build a microservices application using the Seneca JS. So, because today we don't have enough time, so we will divide. I will divide my presentation into two parts, two sections. So the first section we will take a look on what is the microservice, and we will review the main factor when we building up a microservices application, and we will take a look on what is the Seneca JS, and I will have a demo for you. Then we will check what is Docker, what is NGINX, hack and proceed. So before I start, I would like to ask anyone you here, anyone who has experience with Docker? Okay, 1, 2. And anyone has experience with NGINX? 1, 2, 3. Okay. So anyone already here or have experience with the microservices? Or yeah, 1, 2. Oh, it looks good. So in the next section, we will I will show you what is the console and what is the RabbitMQ, and how can we implement the Seneca JS to integrate it with the RabbitMQ to make our system work. And I will show you my code. Actually, I already built a bucket for Seneca JS. It's like a wrapper to help any of you to build another microservice application using the Seneca JS much faster. So I will share my code. I will open source it. In section 2, I will show my code. And then, so let us start. Before we discuss what is the microservices, let's take a look on about the monolithic application model. So this is the monolithic application model. This is very basic and simple one. So this is a taxi hailing application, and you see here we have many services like billing, notification, payment, or trip management. And from our service, we will call a third-party service here like Studio or SendGrid, or we will expose RESTful API, so other service or other client can call. So to use for our system now, we have some issue. Now let's take a look at. Let's say this month you have 200 users using your system, but for next month maybe 5,000 or maybe 10,000. So how can you scale applications? How can you make it respond faster, right? So, and the second thing, let's say all the service run very well except the payment service. So whenever your customer want to pay something, it takes very long time to wait, and they're not happy. So you think about, oh, I need to scale my application, but how? And how can you balance between the cost to scale the application and between the cost to develop something new? So we will take a look on about scale up and scale out. Scale up is related to vertical scaling. It means, for example, right now your application is deployed into one server, and if you want to do a vertical scaling, you add more RAM, you add more CPU, you add more maybe a network, or you can change from hard drive to SSD. So your server is now is run more faster, right? But it's a limit, and when it's reached a limit, then you cannot upgrade your server anymore. And you know, once you want to upgrade your server, you need to pay more money. About the horizontal scaling. Now, let's say today your application is deployed into one server, one physical server, and you say that the system cannot handle a lot of requests from customer. So I need to put one more server here. So you come and you buy for one more server. You put here. So you try to deploy your application into this server. You try to install lots of things there, and you need to put a load balancer in front of that two server. It's called horizontal scaling. Okay, but there is one answer for us. Now, let me introduce you microservices architect. Now, let's take a look on this model. You see here, you have many clients. You have mobile phone, you have MacBook, or even you can have some user here. And all user will be send requests to the API gateway here. And from this API gateway, you see all the hexagon here, the orange one, the brown, or the blue. Each of them is a service. And our applications will be divided into several small of services. And our service will be linked to the API gateway here. The connection between the API gateway and the service can be the HTTP, or can be AMQP, or some of our friends, he already used the Redis to make a connection between the API and the service here. And for each service, it will have its own database. This can be a key value, or we can share one database for all the services. So let me show you the benefit and the drawback of the microservice. First, we elimination of long-term commitment to a single technology stack. Normally, if you build your application using .NET or Java, you have to follow the MVC or the design pattern, right? And for each programming language, you have to learn something new. But with the microservices architect here, okay, I don't care which programming language you use to build the application. I don't care. Okay, you just need to build the service, and you will plug into the system like a plugin. That's it. So even later your system is growing up, and you want more feature, you don't need to change other technology, or you don't need to change the design pattern. And it will improve the false isolation. Like you can, for example, if you have any wrong or you have any faults during the time of service is running, you can know it very fast. And for example, here you have three service or three orange service. Wherever you want to scale or wherever you want to add one more instance of service, you just need to start it. It's very easy. And it's not like Monolithic. If you want to scale the application, you need to scale the whole system. All service will be gone. And it's technology diversity. And let me check the rollback of microservices. First, this will increase the network communication. Why? Because, for example, if you have one request from here, you go to API gateway, the request will be go go to the service, and when the service has been finished its part, it will send back the result. The result will be sent back to the customer or to the client here. So you have 1, 2, 3, 4 branches, and we need to think about how we can serialize the data to send between the message, the service. Let's say we have this service here, and this service here. Now, the blue service want to consume the orange service. How can we do that? Normally, we need to encapsulate the data into the vocal object, and we need to send out. So it's called a serialization data. And it adds more complexity in testing because some service, okay, when you have this system, some service it can be down, or when you start the service and this service is dependent on other service, maybe that service is not ready yet. You get what I mean? So when you test the service A, maybe the service B, which the service A will call to, is not ready. You need to do something for testing. And this will increase the complexity in deployment. So in the bubble of scalability, we have the cube of 3 dimensions. We have the X ASIC here. We have the I ASIC here. We have the Z ASIC. Okay, for the X ASIC, it's more related to horizontal scaling. This means when you want to scale your application, you scale it by climbing. In the Y ASIC, you scale your application by listing the different things. Okay, so how can we apply it into our microservices? Let's say you have, let's say your code, you will try to split, or you will try to put all the code related to login into service A, all the code related to checkout into service B, and all the code related to search into service C. You have service A, B, C here. Okay, so all the code related to service A, when you want to consume it, you will say, okay, use the URI login, or use the checkout, or use search here. So it's called Y ASIC scaling. Okay, for this one, it's an X ASIC scaling because you can add more instance of service A here. So if you see the service A is running slow, you can put more instance, you can start more instance. And when someone here is send a request, let's say this device is want to log in, the request will go to the gateway here and go to here. And from here, the request will be dispatched to one of the instance of our service. So let's take a look on the main factor when building up a microservice system. First, we need to think about we use the API gateway, or we let the client to connect directly to our service. Let's get back to our model here. Okay, we have the gateway API here, but other people they expose all the service here. All the service here, they put a load balancer here, and they expose it directly to outside internet. So the client here, it will connect directly to the service here. This is the first option. The second option is we build the API gateway to stand in front of all service, and the client, it will send the request to the API gateway, and from API gateway, the request will be dispatched to any service inside. Next, we need to think about the stateless and stateful service. Normally, when we build the monolithic application, it's use cookie to keep the user section, right? And that we call it a stateful service. But for the microservice, because we have lots of instances, many instances of one service running, first request, it can come to this instance, but for the next request, maybe it's come to another instance. We don't know. So we cannot keep the section, we need to use the stateless. This means we can use a JSON web token to keep the user ID. We think about how we can communicate between the service. We serialization between the microservice. Next, we think we will check on the service discovery. Okay, for service discovery, it have two things. First is the client side, from the client side, and second from the server side. For example, you have a server here, and you have an AngularJS application here. So from AngularJS, it will say, okay, I want to log in, send a request. But which server? Where is the API address of the server I need to send to? Because you have lots of server inside, or you have many instances of service inside from the server. So which API address I need to send the message to? So we need a service discovery, or from the server. Let's say the message goes to the API gateway, and from there you need to dispatch the message to one instance of service A. So you need to know, okay, this instance is running on this IP address, but other instance is running on other IP address. How can we know the exact IP address to send the message to? Okay, the next three things is more related to the data. When we switch to microservices, we need to think about the eventual consistency of data, and we cannot use transaction anymore. In a monolithic application, you use one connection for database, and you can use the transaction. But in microservice, because the request will go through all servers, so you cannot apply the transaction anymore. And for database, you can share one database for all services, or you can, for each service, you can use its own database. It's up to you. And we need to check on how to apply the CI/CD and configuration deployment. For example, if you have a source code of the project, and normally you put a config file. In a config file, you will define, okay, for this node environment deployment, we will get the config, right? And for the production, we will use this config. Normally we do this. But when you setting up the configuration for production, you push your code to GitHub or somewhere else, then you apply the CI/CD in server to pull the code and to make a build. What happened? Your developer can see your configuration for production. You need a way to hide the configuration. And the last one is service health checks. So I very love this book, Building Microservices. So if you have time, you can check this book. So let me introduce you Seneca JS. Seneca JS is one library to help you build microservices application. It's based on Node.js, and it has been used widely for those organizations. So in Seneca JS, there is two main philosophies. First is the pattern matching, and secondly is the transport independence. For pattern matching, I will have a slide next to this slide to help you make it clear. And for transport independence, with Seneca JS, okay, you don't care. We will use the HTTP or IMQB to send a request from this service to other service. You don't need to care. If you want to use HTTP, you just use it a plugin. If you want to switch to IMQB, it's easy. Just get a new plugin name, or you can run it from memory. Now, this is your first microservices using the Seneca JS. Now, let's take a look. First, I require Seneca here, okay? And I say, Seneca, add a new service. The service will be identified by this pattern, module, match command soon. And this is a callback for this service. In this callback, we have two parameters. The first is the data. This data will be, all your parameters from the client when you consume this service, it will be put to here, the messenger. Okay, and the reply is just a callback. Here you see the reply. We just when we done, we reply, okay, noon is noon. This means no error. And we reply an object of our answer. Answer is the left plus the right. And from the client, we say Seneca, let up. Okay, let's up the module math command is soon, and the left and right here it will be put to message here. And when you have the result, if there is no error, then just log the result here. Any question? Yes.
So is Seneca JS wrapping the services somehow? How, if you say wanted to write something in a different...
Hello?
Yeah.
Hi. So is Seneca JS wrapping other microservices? Like, for instance, the Seneca.add, that module math command sum. Is that something that has to be written in Node, or that's something that can wrap any microservice in any service?
Okay, actually the module math and command soon are just a button. And Seneca JS is just help you as a logical transporter. It means when you say, it will help you to match the button. And if the button is matched, it will try to execute the function.
I see. So in the actual block of the add call, you could wrap, say, a Ruby, a Rails microservice that handled command sum. So say you had a microservice in your services, a Rails app that did that math command sum.
Mm-hmm.
Seneca.add, you could wrap that microservice somehow so the reply would call into
Yes.
the Rails service.
Yeah.
I see. Thank you.
To make you easier to understand the code, I just put all the code in same file. But later in the demo, I will put it in the client and server file. So
Okay, great.
Okay. So let's take a look on the pattern in the Seneca JS. Now, for pattern, Seneca, the author of Seneca, he said the pattern is make easier for you to extend your functionalities. Instead of adding a new statement or adding if and else complex to more complex logics, you just need to add more pattern. Okay, now let's take a look. We have the module math here, the command soon. Okay, so it's very easy that we just want to add two left and right number, right? But what if we say the left is 1.5 and the right is 2.5, and we say we want to add, we want to execute the function to add the integer only. We want the result should be integer, not a double. Then normally you need to put more logic in this function to say, okay, if the left is not integer, if the right is not integer, then we need to convert from the double or float to integer, right? Normally we need to do this. But for Seneca, okay, let's forget it. The first time you say Seneca add, and this is your button, module math command soon. And the next time you just say, okay, module math command soon and integer 2. That's it. Easy. Now, I will have a demo for all of you here. Normally I will show you the basic one first, and then I will show you from the server and the client side we make a request. And then I will show you using the AMQP, but this one will be for the next section, okay? So let's take a look at the basic one first. In my package, I will add two dependencies. The first one is the Seneca package, and this one is for AMQP transport. So you don't need to care this one. Check the basic one. I have service test here, I have command soon. And let's say when this function is executed, it will try to come back. The answer is data left and data right plus data right. Let me run. You see the answer is 3 here. It's because when we send the left and right here to this into this service, it will do the calculation. Now let's run it from client to server. Now in the server, I say, okay, use Seneca, and I register my service. And then I say, Seneca, listen. A listener or a server, and from the client side, I will say, okay, client require from Seneca, and it's up like a client. And from the client, and I say up the service, and the result will be stay here. And one more thing before I run the server and the client side. You see, when I add a pattern for service, I use string. But from client, I use object. It's supported by Seneca JS. This means you can define your pattern using the string or using the object. Seneca will understand. So I start the server here. I start the client. You see the answer is 3. It's because when you send the request to server, when you send the request to server, the server will send back the result. Now let me to help you understand more clear, I will attack to debug directly to the server here to see what happened. Okay. Now get back to the client side. Oh, no need. You see, when I run the Notch client side, it will send a request to server here, and you see the data. There is left is 1 and right is 2, and it has been encapsulated into the data parameter, and then it's just a callback. So what happens when you say Seneca.listen? When you say Seneca.listen, it will try to open a box on your instance on your server. Okay, normally it will use HTTP for the transportation. If you want to change or if you want to use another transportation, you need to define first. For example, this is the server IMQB. The server for MQB. I say require Seneca and I say use Seneca AMQP transport. And when I say listen, I need to configure the transport by provide the address of the RabbitMQ server. So this will be for next section, it's not now. Okay? Now let's get back to our presentation. So to build a microservices system, there's many things you need to, many applications, many third party you need to use. First is Docker. Secondly, you need to use RabbitMQ or consoles. So why we need to use Docker to deploy the microservice application? Now let's take a look and see what's the difference between the virtual machines and the Docker. Remember that we need to scale the application by cloning the application, right? So if you want to clone, then you need to put more server. And normally when you buy a new server from, for example, the VPS, then they will ask you, okay, which operating system you need to install, like Windows or Linux, right? And then when you have a server, then you need to install lots of things like IIS, .NET, or Apache, Java, blah, 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 lots of things. And after that, then you need to install your third-party application, and then you need to deploy your application. So there are lots of things to do, and you see, you waste money because for each virtual machine, you need to install your operating system for nothing. So now we have Docker here. With Docker, okay, you have one physical server, and you will install the host operating system here, and then you will install Docker. It's work like Docker machines. It will share the physical resource like CPU, RAM, and it will also share the host operating system binary file to all the container. All your application will be deployed into a container here, and you only need to aware about your binary third party, your binary code. That's it. So, any question about Docker? Okay. Next, we need to know how to use NGINX. NGINX is normally is a HTTP and a reverse proxy server. It also can be used as a mail proxy server. So why we need to use the NGINX here? Because of the performance, scalability, availability, and easy. Okay, let's see how it works. For example, you have many clients here, and you need to put one load balancer server in front of all of your service server here. Then you need to install NGINX into this server. So when the request comes, it will expect the request to all of your server here. Instead of using NGINX, you can use H8 proxy. It's the same function, but NGINX is more easy to use. Okay, so it's time for question and answer. And then the next section, we will take a look on the RabbitMQ, how to implement the AMQP transport to integrate with Seneca JS, and we'll see Seneca JS integration with the console, integration with AMQP in action. I will show you the demo that we will run lots of service and server, and we'll see its load balance. The message will be distributed. Okay, so any question here? Okay.
Thanks so much for the presentation. So I'm just trying to understand, Seneca JS is like a competitor to say something like Kubernetes? Google's Kubernetes project, as far as like orchestration?
Kubernetes, okay.
Is it a complementary product, or is it a competing product?
What do you mean the connectivity?
Seneca JS, is it something that can be used to, say, orchestrate your microservices application, the whole cluster, like doing something like rolling updates? Service discovery obviously is something that it does, right? So a lot of crossover into something like Kubernetes. I'm just trying to understand, is it something that's overlapping? Can they be used together in a deployment?
Okay. Actually, we cannot use Seneca JS just by itself. We need to integrate with other systems. For example, I have. If you go to, if you follow me with section 2, you will see my model here. You see, you will use the Seneca JS. We will need a gateway API here, and we install the Seneca JS in this service here. This is later. This is section 2. Okay. With Seneca JS, it's only help you to it's like a logic expector. It's like if you say the correct pattern, it will help you to execute the function with that pattern. That's it.
I see. So it's really just about connecting different services with specific APIs?
To implement the connecting between the services, you need to maybe you can use the HTTP, or maybe you can use RabbitMQ is a broker, and the message will be sent to a broker, and broker will be display the message to a service.
I see. Okay, thank you.
Any other question? Okay.
Thank you for your presentations. I have a question about Docker.
Docker, okay.
If you your products, you have more service. Yes. In production, what service you to monitor?
Okay. You're asking me that which service we need to use to monitor on the Docker container, right?
Yes.
We have the UI to monitor the Docker container. Normally, Docker is free, and it's allows you to install your server. If you pay money for commercial version, then you will get a GUI to serve it, health check. Okay, I don't have Docker with me right now. I can open this one for you. Yeah. While I'm looking at console, any other question? I will try to answer. Okay. You see, monitoring console health and performance. Console normally is a key value database. Is also it can act like a service discovery. Okay, but with Docker, we have a plugin to help Docker and console to know each other. So wherever you start a new container, console is like, oh, you have a new container, and you can register a service health check. And here you see it can check your container like CPU or other things. It depends. It's up to you. You can register the configuration. And then, okay.
Yeah. So could you please go back to the slide about your architecture, microservice architecture, with like gateway APIs?
Yes.
Yes, this one. So like, so in this architecture, I think, do you think we would need to scale the API gateway because it might be the bottleneck for this architecture?
Yeah, that's for sure. Because if you don't scale the API gateway, then you will get 1 point of debt. Once your API gateway server down, the whole system will be down. So normally we need to put more than one server as an API gateway here, and we will put one load balancer in front of that two API gateway.
Okay, thank you.
One more thing I want to say, microservices is not a silver bullet. So if you want to apply the microservices for your small application, then you waste time. Because microservices is designed for a big and enterprise application. You want a big application, you want your application that can be managed or can be scaled easily. You want your application that one service can be scaled and can be iterated very easy, then you apply microservice. But if you just write a small application, then you waste time because you need to implement lots of things. You need to implement lots of things. Any other question?
Hello, I don't have many experience about
Okay, it's a good question, but today I don't have any preparation for this. Maybe I will put in a section too. Thank you for this question. Yes, please.
Okay, I see that you have. So there's two ways to come to a Microsoft system. What I wonder is the security.
Security.
Yeah.
Okay.
So if we build everything is called via API gateways, we have to secure for the API gateway, right?
Yeah.
But if we call directly to the microservice, we have to take care of security problem for several microservice system. Right? Is there any solution for that?
Yeah, that's a good question. So let me share with you about the security. Normally, all the services from here, it will be your internal network. Okay, so all things will run your internal network, and maybe you can trust this. But from here to the API gateway, it's from the outside too. So you need to secure that part. Maybe you can use the SSL, or you can use the token to check the request. Okay, so from inside the network, for the service calling to each other, service can consume other service directly using the HTTP, or service can consume other service using the broker like RabbitMQ. So if your service A is connected to broker and service B is already connected to that same broker, I think you can trust that two service. So we will not care about that. But in my package, I already told you that in section 2, I will share my code about my package to help you easier to develop the microservice application. In my package, it will also to help you implement the security. It will help you to say, okay, if service A trusts service B, then the request will be processed. If not, it will be dropped. If the request from that user is not authenticated yet, drop. If not much, the role drop.
Thanks. Thank you.
Anything else? I think maybe one or two more questions. If you don't have any question, then I can finish my presentation here. And I hope that you can come with me for my next section of my presentation. In the next section, we will see in detail how we can use the RabbitMQ and IMQB in Seneca JS.
can we have the feedback form now? Now we will come to the most expected part, the lottery game. Our system will randomly choose the lucky guy. Okay, are you ready? Go. Number 39. Are you here? It's on your name, the paper. 39. No one? Okay, again. 21. Who is 21? No one? 43. 43. No one again? Okay, the last one. 11.
Right here.
Okay. Please come here to receive it. I would like to invite Mr. Hùng to and I would like to invite our presenter to come here to receive the gift from the developer. Mr. Huy Trịnh, Mr. Song Lê, and Mr. Trung Đạt, please come here. And Mr. Minh Đức and Thảo Huyền, please come here.
Okay, let's see.
Okay, it's the end of our meetup. Thank you for joining us today, and it's time to networking.